So people wanted to have a retrieval augmented generation system where I say something to a large language model, it then pulls context from my own documents, but not the whole document. Otherwise, we're going to kill the context window here. And and then what's going to happen is we're going to query that database. We're then going to put the context in the prompt and then return back an answer. And in a lot of situations, one of the challenges around this is that with a large language model, anytime you put context into your prompt, it will forget the instructions that it was trained on if your context is either too dense, blows the context window, or has too many jumbling words of too many different types. And so then DeepSeek made, I think they made a different way to query the vectors where it was almost like how I think about, like partitioning a document database where if you want to have horizontal scaling, so like you have two types of databases. You have one that's going to scale horizontally, meaning like if I have this database and I need it to grow and it's on one computer, I can put it on 10 computers. And that describes like a NoSQL database, NoSQL being not only SQL. But then we have a vertical scaling database, and this is what Postgres is. This is a relational database. So if my database grows, like in the worst case scenario that PhonePe was ever doing like everything inside of one Postgres instance, which I don't think they would, but just kind of putting that example out there where payments can scale to the billions, trillions, quadrillions just because of the volume. Your Postgres machine, you might say, hey, first, all right, it could definitely fit onto a MacBook. Then you're like, okay, now it's got to fit into like a special piece of hardware. Now it has to fit onto an even different machine, and it's only on one machine, and it continues to consume more resources. So in this situation, what DeepSeek did was they used that horizontal scaling model. And this is how I'm thinking about it. It could be wrong, so correct me if I am wrong. But like with that horizontal database, how do you scale it? That's scaled through partitioning. So if we're scaling the database, like we're storing a bunch of names and we're scaling it from one machine to 10 machines, we're now saying A through B is here, B through D is here, E through F is here, G gets its own machine because it turns out that 80% of people have their last name starting with G, right? And then so on and so forth to like have some type of breaking. And so then what I think they did was they implemented a model where they're like, okay, great. He's asking about this, but I'm not looking that up right away. I'm not getting that specific. I'm going to go one level up. And then by going one level up, then I'm going to query, and then I'm going to find the better places in the bottom. And I think that's how they did it, but I could be wrong.
I think you're right. But in addition, I believe they also implemented their own version of a file system that is distributed across each of these instances. It's called 3FS. So they built their own file system. So multiple machines would act as one single machine. It's like one big machine, but the hardware is distributed. And then that's how the database was partitioned and distributed across as well.
And so this is for the LLM server at runtime, or is this for like,
This is for training as well, I guess.
oh, for during training time as well?
Hmm.
That's
And that
actually brilliant.
it is. And
It is
right.
actually, yeah. It's basically like if you think about it, it's pretty brilliant what
So
they have
what the
done.
hell does this mean for the demand for Nvidia? Because before everyone was like, okay, Nvidia's going to the moon because no matter what, we're going to be demanding these chips. But then you
Mm.
have the efficient market hypothesis where some folks then started saying, okay, well, I can reason from first principles. And I know that if this is hardware, what we can do is we can burn some stuff onto the processor directly, and then we may have a chance to compete against the NVIDIAs of the world by being able to design our own chips. That was one idea. But now that we have this frame of reference where I guess this model that we were talking about, this is called the multi-headed approach.
You could call that, yeah.
It's something to that effect of what we are just talking about with the vectors and the partitioning. But this multi-headed approach now means like we're using a lot less compute. And if we're using a lot less compute, we need a lot less specialized machines. But then at inference time, if we're also using less requirements, and then at inference time, like, can you get the requisite chips into all of the data centers that need it, along to all the places where the edge workloads are? Probably not. And you have one, I don't know how many different models of chips NVIDIA has, but that one main GPU hopper they have that retails around $400,000. I wonder if it still matters in the supply chain, or if Grok with the Q can come in and now be like, no, 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 everything's happening at inference time. The commercial markets may not realize it, the capital markets don't realize it, but the consumer layer who's going to be buying this stuff, they're going to know. And then eventually things are going to even out in another. And then we still don't know. I mean, it's only been 45 days since DeepSeek released. And like, if they release in another 45 days, because like 4.5 got released, right? 4.5 got released last week, 3.7 got released. So DeepSeek may come in and be like, you know what, fine, we'll just release again, which would be crazy because they released a whole lot. R1 is not the only model in their fleet. There's many, many other models that led into this moment, and they move pretty damn fast.
I actually have a comment on this particular thing that you just mentioned. So I have a background working in the semiconductor industry, and I have seen things forefront because I was working with the company that actually builds the machine that builds the chips.
Oh,
So
yep, I know who you're talking about.
yeah, so just imagine when I was working in that team, our product was being shipped to customers like Samsung, TSMC, and Intel. And if you think about it, the innovation, it is like basically, you can call it vertical or I don't know, you can call it vertical innovation. Is basically like your area, the area of the chip has not changed, right? It is that rectangular or square shaped box. The only thing that has changed is like how many transistors can you pack in that same surface area?
Moore's law, correct?
Yeah, exactly.